Hi everyone, welcome to Flutter at Scale, the talk about how we built a large mobile banking app with over 25 Flutter developers working together on the same code base. It's kind of our lessons learned, so maybe you will relate to that. Maybe you had a similar experience with some clients. Yes, so let's introduce ourselves. I'm Mateusz. I'm head of mobile at LeanCode. Using Flutter since early beta, I guess. And in CABP project, because it's a Crédit Agricole Bank Poland, I was the leader of technical squad. You will know what I mean later in this talk. You can find me on Twitter X at this handle.
And hello everyone, I'm Albert. I'm working with Flutter since its very first public release, so the 1.0. In the Crédit Agricole project, I was working for something like 2 years as a leader of the overall design squad. Yeah, you can find me on Twitter.
Yeah, so let's start with setting some terms, because what it means for a project to be small or large. Let's try to somehow set this term. So small project, from our perspective, is a project that can be done approximately for 2 months with 2 people. And how to recognize this project? The project is small when you know almost every piece of code. You know this type of projects where you probably know everything about the project and every developer knows almost every piece of code, and you got similar business knowledge to your colleagues, and there's a big chance that a backend developer also sits by your side and you can communicate with them in real world, which is very, very helpful, and very helpful especially in this kind of projects. So what are large projects? In large projects, I think the main differentiator is there's code that you have never seen, and there will be code that you will never see. This is very important because you work on loans, but you don't know anything about loyalty club, so there are 2 different business domains from 2 different separate teams in terms of development. So there's code that you will never see, and you have to accept that because there's hundreds of people involved from different companies. Each of them works in a different way, different workflow, different time zone maybe even. So let's tame it and how to work with that. But first, what was our project? Well, our project was over 200 people involved, not only in the development, I mean the whole project, also from business side. So in development, Flutter development, over 25 Flutter developers in more than 10 squads. We tried to list all of the squads, but they are changing over time, depending on the business requirements. But we emphasized 2 of them that are most important today, which is squad number 1, overall design, which was mainly responsible for the whole design system implementation and consistency, which Albert was the leader of. And squad number 13, platform and framework, also called the technical squad, which I was the leader of, and it was responsible for things that no one else wants to do, as you will see later. So when we thought, how can we deliver a large project, we thought of 10 key concepts, but today we will cover only half of them. If you want to know more, you can download our white paper on Flutter for Enterprise at leancode.co. And you don't have to type this link, because at the end of this talk, we'll have a QR code for the ebook. So let's start with the first key concept, which is code ownership. It's a seemingly simple thing, right? In a small project, it's simple because we all own the code base, we all know anything, we are all responsible for it, we all develop new features, fix bugs, and maintain it. So the project has more than 25 Flutter devs that work on a single app in a mono repository on a single code base. And imagine that. And is everyone responsible for everything? Everything as in nothing? The answer is no, because there's always an excuse, and you probably have already seen this kind of projects where anybody can tell someone else is responsible for it. No one can actually check if it's true, so everyone can say, I won't maintain it, it's someone else's job, it's some other team, some other business domain, and no one is responsible for anything. So if we want that there's always a responsibility, we need to set some boundaries and impose some rules. So to disallow no man's land in our code, we have to introduce explicit code ownership. So let's set some rules. The first is every piece of code is owned by a team, not by a person, because people can change teams, squads, positions, jobs, everything. So it will break our rules, so we want to have every piece of code to be owned by a team, for example, payments squad number 7. And the team takes full responsibility of the code. What it means is they will maintain it, fix bugs in it, develop new features in there, but the most important thing is this. They will allow or disallow any new code in there, because still we don't want to stop you, we don't want to break your velocity. Imagine that you depend on other squad, and for example, you depend on some one method from some facade that's exposed by, I don't know, accounts team. And you know that it's a one line to be fixed so that you are unblocked. So we still want you to be able to fix that and just make this pull request. We just need this team to approve it explicitly so that we know that they've seen it and they put their own approval on it. That's why it's really important, so that you can still contribute to their code base, but it's still owned by them. And the third rule is that there are no exceptions to those rules. This is pretty important, because otherwise, like in any large project enterprise environment, the rules won't work, right? We have to enforce them. So we have the rules for some specific places in code, but how to define the boundaries between these places in the code. So I think that there are multiple tactics for that, but in our case, local packages was enough. By local packages, I mean Dart packages. We had 60 or 70 packages in our project, and each package is owned by a team. We have some explicit markdown document about that, and we know that this package and this package is being owned by squad number 5, for example. And it was enough for us. But you could say, okay, but there's always something common. This is correct. Actually, it's pretty correct. There's always something common. And it's not a problem as long as it's being owned by a team. So if you have any common packages, you can still have them and still have explicit code ownership. You can just, you have to assign them to some team, because we have no exceptions. And here comes the technical squad, the team that maintains code that no one other wants to. So we just took all the packages. If any squad was, for example, closed and dismissed, we just took the code and split it out on other squads. Or if no one wants to do it because it's not related to any business domain, we just take the code to us. So the summary of this part is someone has to be responsible for each piece of code. Okay, so let's go further. We have code ownership, and we want to plan some project structure. And we can look at project structure for a whole different, like many different perspectives, as you know from articles, books, and blog posts. And you've seen a lot of diagrams like this, probably. We have 9 classes in here. We have some pages, which is UI. We have some qubits, which is some application logic. We have some repositories, some data access layer, from 3 different business domains: transfers, loans, and benefits. And you could see many times that people use this layering in this horizontal manner. And you could have UI package with all your pages, application logic package, repositories package. Okay, but we have to ask one significant question. Who owns the package, right? Because who owns the UI package? So let's try to answer that. And we can refer to some very popular aphorism in computer science. That's Conway's law. And it states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So let's try to relate to that. It means that the communication model of our organization will project onto our code, no matter if we want to. So let's try to ask ourselves, how do we communicate on a daily basis? And daily is the key word in here, actually, because we have daily meeting. So is there a repository squad daily? Is there a UI squad daily, application logic squad daily? No, in our case there wasn't one, but it was payment squad daily, benefits squad daily, loan squad daily, because there are some payment business experts, people from other side of company that we depend on, people from other companies that depend on us, and the one and only thing that connects all those, I don't know, 30 people is that we all work on one business domain, that is payments and transfers. So let's try to project this communication model onto our code. So we can still have the same 9 classes. We can just group them in an orthogonal way. And as you can see, we have transfers package, loans package, benefits package, for example, and which is good because now I know who I should ask about this piece of code. Because I know, okay, this is transfers, this is squad number 7, for example. Okay, but you could ask, what about the package structure inside? So what about the files inside one package? And still, you can approach it in many correct ways. This is just the one that we took. We thought, okay, if we go domain-driven, still we want to go domain-driven. So we love feature-based architecture. We just have a directory of features. And for example, we have lending, which is about giving loans. And we have agreement documents because you have an agreement of loan and you have some documents to sign. And as you can see, all the code related to agreement documents is in the one directory. It's also helpful for onboarding new developers because in large organizations and large projects, you will have a lot of changes in terms of staffing. And when new developers come and you want them to look around agreement documents, you can just tell them this is the directory. And if they would imagine to try to search the whole code base for pieces of code related to agreements, it would be really cumbersome. So it's really helpful for also for onboarding and tutoring. But one question raises that was asked before when we made this presentation, how to do the wiring. And always remember that you have your entry point package that still has to depend on anything that you use in your project, even if you have 60 packages. So you can use those packages, this app package, as your connector, as your wiring, for example, to get providers from other packages and inject them into tree. Or, for example, inject some public interfaces like some facades to be used to other squads and so on. So the summary of this part is take a domain-oriented look always, because it really helps in terms of grouping and making decision about the project structure. Okay, so let's start actually working on the code, because we have everything on paper, but we don't really start coding. And we can see a lot of packages, and we think, okay, we have a lot of packages, and now I want to run tests when applicable. Or maybe I want to generate code only in packages that have CodeGen. It sounds horrible, but what we essentially want to do is we want to run things in a multi-package environment. So it means that we need a task runner. And there is something like that already. Fortunately, there is already something. We didn't have to write our own task runner, because there's Melos, a tool that's basically a task runner for Dart ecosystem. And this is really awesome. It's a CLI tool for monorepos, just like ours. And it's used by Firebase, Flutter team, Flame, Flutter community. And we used Melos. It's from Invertase, just to mention. And we use Melos for getting all packages, generating code, running tests, reconciling package versions. You just need a task runner. But one more thing about consistency is use one lint package in those large projects. You will thank us later, because probably you will have those weekly meetings with all the Flutter developers. When you agree or disagree on some new lints, you will migrate to another Flutter version, and new Flutter SDK has new lints, or new Dart version has new lints, and you will have to agree on, we activate this lint, we deactivate this lint. So you can do it in one package and just import it in all other packages, so it's much easier to maintain. Okay, so let's go further. In any large enterprise project, they will ask you about end-to-end integration testing, because they have some standards, some compliances, and they want you to prove that you can integrate test end-to-end the app. So we tried to do it, and back then we used Appium Flutter driver, because the QA team already knew Appium, and they had Java code base, and they wanted to use that, so we tried to use Appium Flutter driver. But it was pretty unstable for us. We had to fork it to fix some behaviors. We had to fork Flutter driver to expose some APIs that weren't exposed, but the QA people really want them to be exposed. So we had to fork a lot of things. And now we created another solution for that, which is Patrol, which bridges the integration testing and Flutter test world of your Flutter finders with native site. So you don't have to go out of Dart code. And if you want to know more, you can approach us after the talk.
Okay, yeah, so if you have a project of this scale, you rather certainly need something like a design system because you want to enforce the consistency and reusability of all the work that your developers basically do. And just to remind you, we had rather a big amount of different squads that were working on a single project, on a single code base. And all of those squads, with the exception of the overall design or the platform and framework, were actually producing a business value, which was requiring creating screens, the pages that the end user sees. And those screens need to use some components, some maybe material components, maybe Cupertino, and maybe our own design system components. And as a result of this squad-in-one work, we created over 350 different components, from very small ones to very complex and big ones, and almost every one of them had their dedicated page in the storybook. So, given all this experience, a question arises: what do we actually need to do? What do we need to cover? What do we need to remember about to create a good design system in Flutter? And let's start with the basic stuff. With the tokens, and let's start talking about them from the designer's perspective. So to those who don't know, tokens are basically something like variables in your source code, but in Figma and Adobe XDR, whatever tool do you actually use, it allows your designers to not hard code the different properties of the text cells or other things every time they need to use something, but rather define only a specified set of the typographies of the text styles or other things, and then reuse it in the component. So we could have this headline 4, for example, with some font weight, font size, and other properties, and then just simply use it inside the button, simply referring to it as a token and not hard coding all of the properties that it had. And it's the same story with other things like the colors. We also not hard code the colors inside our designs, but rather saved into our tokens, and also use those tokens in our components. And there are many different things that we can tokenize. With the latest Figma update, they actually introduced much more powerful tokenization features. But maybe the designers also use Token Studio, which also gives them plenty of different options, or other software. You can tokenize stuff such as spacings, some elevations, box shadows, basically almost everything that is reusable as a value, as a primitive, or as something in the designs. So this is how we have it in the designs. Now let's talk about the code, because we also need the same tokens inside our code to prevent developers from using some illegal ones, because maybe the developer made a mistake or the designer used some hard-coded one, and it also makes it very easy to spot and fix inconsistencies in our project. And for the typography, let's take a look at how we approached typography in the code. What we did is we basically extended the default Flutter text style class, nothing really fancy. We gave it this CA prefix so that whenever a developer sees anything prefixed with CA, which stands for Crédit Agricole, by the way, the name of the bank, they know that they are dealing with something that comes from our design system, from our common UI package. And what it does, it only holds all the values we care about, but it has very important aspect. It has a private constructor. You could also make it internal if you like it more. And what it does is it makes it prevents the developers from creating instances of this CA text style outside of this file, outside of this library. So it's only you, the overall design developer, that can define all the different instances of this class. Like here, we have some CA textiles class, which basically holds all the different instances that we have agreed on with the designers, that the designers also have in the Figma. And in all of our components, we do use those CA textiles classes and not just the Flutter one, the textile, because we want to prevent developers from using anything they like and stick to what the design system allows them to use. And the typography is rather basic in this regard. And it would the setup would be very similar to other stuff like the spacings and the box shadows probably, but in the case of colors, it gets a little bit more complex because colors, you usually want to have some different kind of colors, some different color palettes, like the light and dark color palette. Basically, every application right now has something like this. Maybe you're creating your application for some government entity that needs to follow some very much stricter accessibility guidelines, and you need to have some high contrast color palette or something like this. And we approach it very similarly. We also create our own class that has a private constructor. We define all the different tokens that there were in Figma, and in different color schemes. We can have light color scheme and dark color scheme, let's say. You can even have something like a different color schemes depending on the context of your user, whether it's a company user or just a normal user. So we have those color schemes. What we need to do now is somehow pass them to the widgets, and we use nothing else than the inherited widget. Like the most simplest and most advanced thing in Flutter when it comes to passing stuff down the widget tree. We just pass the correct color scheme data to this and then retrieve it in our widgets. And how do you do it? How do you pass it to this inherited widget? We have somewhere at the root of our application, basically a place where we decide which color scheme we want to pass, whether it depends on the platform brightness when we have just the light and dark, or maybe we can have some dependency, and that's in the application logic between different types of users, where we can give the user some company branded color palette and maybe some consumer one color palette, and that's what we actually had in the banking app. And for using those colors, sorry. It doesn't really help here. And how we use those colors is it was as simple as calling context.colors. Whatever color you defined. The colors is just a simple extension getter on the build context, which retrieves the value from this inherited widget that we defined before. And I can give you a few tips right now about this stuff. So if you're having a text component, your own text component, which you probably have because you want to enforce using those your company textiles and colors, then it's very handy to accept the style and the color separately, because it's very rarely those two, the style and the color, are actually connected to each other, so it's more convenient. And the other one related to defining the colors, defining the color tokens, and it's very important. I put 2 exclamation mark emojis here, not without a reason, is to think about your color tokens and how they connect to each other, if they are in context of each other or not, because if you won't think about it, you might end up in a situation where you have such design system where you have like this very simple app with 3 color tokens, the primary, white, and black. And this is our application. It all looks good. I mean, the text is legible. We have the proper contrast. But then our product owner comes by and says, hey, we need to have the dark theme now. So we have whole application already developed. So we just swap the values of the colors. Probably it's something like this. We we invert the white and black and make the primary probably a little bit more dark, but then we end up with something like this. And this is because the primary and white color tokens never were meant to contrast with each other. They were just white and some branded color. This is why it's very important to use more contextualized color tokens like those. We have primary and we have on primary, which is a color that is always contrasting with the primary. We can have also some other states like on primary muted, on primary active, stuff like this, but they need to express this relation that they contrast with each other. And with this setup, it's very easy to create a dark theme, which is correct, which has all the correct contrast and the text is legible. And this approach allowed us to create such a beautiful experience in our banking application. And yeah, when we have so many different components, it starts getting more and more important that we are aware that those components still look good. That's when we modify one component that's used in a few other components, that our whole application won't break, or if one process in the application, one certain page won't break. That's where the golden tests come into the game and help us. And what are golden tests? Golden tests are something very similar to widget tests. Maybe I'll just use the keyboard. So you do what you do normally in your widget test. You pump some widget into the screen, but then instead of actually doing some expectations based on whether you can find some text, whether you some callback was fired, you match against a golden file this widget that you just pushed. And what is a golden file? Golden file is basically the rendered version of your widget. That's a PNG file that's outputted by the Flutter test tool when you add some additional parameter like generate goldens, if I'm not mistaken. And golden tests are really helpful. It's a great tool because it allows us to spot those differences, those mistakes that we made along the way, or those places where some regressions slipped in, which also boosts our confidence when we do some more low-level changes. Maybe we change the value of some color in our design system, and then it's very risky because you can't be really sure. You don't always remember where it was used, in what context. So golden tests can help you be sure of that. But they also have some limitations related to the CPU or the architecture on what platform they are being run on. And when we commit the golden test to our repository, then we also see them in our pull request differences, which is also helpful because your code reviewers can also take a look and visually tell whether your widget changed the way it was supposed to change. And there are also a few packages like the Golden Toolkit and Alchemist that help the golden test set up a little bit. This is one example. This is using the Golden Toolkit, and Golden Toolkit here helps us to create a different matrices of all the different devices that we run tests on, like the color theme. In this example, we have two different color themes, and the golden test generated those two goldens. We actually had only one golden test, and this generated the golden for those two themes. And it also outputs us very nice visual difference whether something failed. We can see what pixels visually failed, which also helps in debugging. And the last thing, Storybook. Storybook in our project was really helpful because it was a place for the developers where we could focus on the development of just this one component. We didn't have to deal about all the surrounding business features, about all the different dependencies that came from the business logic. It was also a place for other developers where they could see how the components looked like before they get a chance to use them in in the source code. Also, it was very helpful to use them in the storybook in sprint reviews. And for designers, or basically anyone involved, to check whether the components that we developed were working good, were behaving properly, and were their appearance was as the designer told us it should be. And this is how our storybook looked like. Very simple. I mean, it was very simple. On the left side, we had the list of all the different components with some search. On the right side, we have a panel of different knobs that we had to define. Those were basically the parameters that we passed to the constructors of all the different components. We could also change the theme on the bottom right corner. And on the main portion of the storybook was, well, the component itself. And it was helping us not only with such small components, but really used everywhere, like the button, but also a very complex one, ones like this. The CA scaffold panel over, very fancy name, is probably the most advanced component in the whole application. And the storybook also allowed us here to play with it with our mouse or with our finger on the mobile device to check whether all the scrolling behavior is working nicely as intended. And back then, we didn't really, it was like 2 years ago, we didn't really have a very good solution on the open source market to achieve storybook like this. This is a very heavily modified Flutter_storybook or something like this. But now we have a very good open source solution that has all the features that we had to add to it out of the box, which is the widget book. Yeah, that's a rather old screenshot. Widget book guys are also here on the conference, so you can say them hi. They also have some cloud collaboration tools if you need it. And yeah, this was all when it comes to our presentation about creating Flutter applications in the enterprise environment, but that was certainly not everything on this subject. We have many more different topics covered in our ebook, which I heavily recommend you to download, to take a photo of it, follow the link, and that's it.
Very interesting, thank you. Especially for me, I have also been working on a banking app for like the last 1.5 years or so. And one of the gold sponsors out there, Scandia, I don't know if you talked to them, but yeah, they're also doing something similar. All right, let's get to some questions. Why not just use Flutter theme?
Flutter what?
Flutter theme.
Theme.
Good question. I think this is because we wanted to not use the material components. We didn't want it to have those materials defaults and be impacted by the decisions that the Flutter team makes to the material components, which they actually do. Like recently, there was this material free update and some things changed. And when we had only our own theme, only our custom components, it was us that were responsible for basically 100% of the pixels that were seen on the screen. But it's not just the pixels. When you are creating your own design system and not using like the material or whatever from the Flutter under the hood, you also need to take care of much more stuff like the like to make all of those widgets to be accessible. And probably many more.
This is, I think, very important that if the design system doesn't depend itself on the material design system, then we also shouldn't, because it would be harder for us later. You know, all the behaviors that are made in material are made because they are in such a way in material design system, and not every design system follows the rules of material design system. So that's why.
Makes sense, thank you. From Ayman, what's the advantage of creating your own design system rather than using the pre-packaged design system like Material, which is flexible as well? Almost the same question, but a little bit different.
Well, I think when you're dealing with big clients that have big budgets, and big teams of designers, you probably want to have this brand recognition also inside your application, and the application should follow those brand rules so that when the user plays with the app, he knows that it's okay. It has the same branding, it uses the same colors, it has the same border radiuses that they use in the commercials in the TV, stuff like this. And this makes this connection between the user and the actual company that is giving the value through the application.
Yes, also I think that if everyone would use Material, every app would look the same. So that's why companies don't want to look the same as the other competition app.
All right, let's move on to the next question. Why not use a third-party state management solution? Did the use of your own testing framework inform this decision? From Mark Vidion.
We used mainly blocks and qubits for state management because we also worked with other companies, like developers were from different companies, and block/qubit is something that's pretty much known for any Flutter dev, and it's flexible enough so that we could fit it in our architecture. And about testing, I don't...
Did the use of your own testing framework inform this decision?
Your own, like, patrol? Or
I don't know. It sounds like Mark thought that you had built your own state management.
No.
I'm not sure.
No,
yes,
no.
is Mark here?
We used qubits blocks, but it's on the application logic layer, so you can actually replace it. You don't have to use qubits and blocks because we try to... every package has a public interface. It's another package, for example, accounts public, and it exports facades and interfaces to be used from outside this library. So it doesn't matter what the state management is being used inside the package because it's just a stream outside. So you can use, for one feature, you can use value notifier, and for other, you can use some other stuff like MobX. It only matters that you expose a proper minimal facade, and it's cool then.
All right, makes sense. What kind of CI setup do you use? Package-based workflows, etc.
Internal CI/CD because it's enterprise. So we had internal Jenkins. We have merge request pipelines because we use internal GitLab. So merge request pipelines when it comes to creating a merge request, editing it and stuff like that. And also, I think every hour there's a build on the release branch about the setup. What do we do? We run Dart analyze like everyone. We also scan for vulnerabilities, especially now when Flutter and Dart is supported by OSV scanner, and you have access to GitHub vulnerability database and more. So we try to use that. Also, we used some license tracking, stuff like that. So a lot of compliance stuff that you have to run in the banking environment. But nothing fancy, I think, beside that. Also a bit of integration tests, because we have regression tests that are being run nightly, and we have 3 or 4 integration tests that just check if you can make a transfer, for example, something that's really necessary for a banking app. And if you can't make a transfer, then it won't merge or something like that. I'm not sure. I don't remember right now, but something like that. Just ensure smoke test.
All right, let's go.
And running unit tests, of course. Unit tests on every, but it's something that's obvious, right?
Yeah. So from Alfred, how does the code review / PR process look when you have multiple teams involved within a new feature / bug fix?
If you touch code base owned by some team, a member of that team has to approve this. Yes, pretty much like this. And sometimes if you touch something that's global, then technical squad also has to approve it, kind of. But it's kinda implied from the first sentence. So yeah, the first sentence.
It's also because it's always the squad that is responsible for a given piece of code that has the knowledge to really tell whether the code they are reviewing is correct, whether it doesn't fail to meet some business requirements they were developing before.
Because other devs from other squads can check the style or things that are related to development itself, but they don't know the domain. So we also require that one person has to be from the same business domain, because they can, check the domain rules.
All right. Last question from Slava. How was your IDE experience with so many packages?
Horrible, to be honest. But it's not like we complain so much. It's just I think that we still would go with so many packages because it still is better than having all of those 60 packages inside one package. But if we had to do it again, then we would make more example apps like the inside project so that people can run only one window in VS Code. Because, we try to work it around, because the main problem is with Dart Analyzer that we have 60 packages and everybody goes out of memory in, 10 minutes after starting work. So you can either kill all Dart in the terminal and restart 10 minutes, or you can wait 10 minutes for auto-completion, which is also not so bad, like in comparison to other solutions. And you can also exit the workspace. And I don't know, I know that Dmitry from Dart Code Metrics told us that why it happens, but essentially you can open, because normally you work on 5 packages, probably max, in the same feature, I mean. So you can open those packages in separate windows, and then everything works super good. But sometimes you want to have all the workspace open because you want to search through all the code base and stuff like that. And this is really bad. But I know that the Dart team is aware of that. There's an issue about the context and stuff like that. So I know that they work on it. And I know that Dmitry from Dart Code Metrics also found some solution. So I know that there are workarounds, and now I think that there are also solutions in progress. So I think that this is one of the most important things from the perspective of developer experience in huge projects, because we also on FlutterCon we spoke to other guys that had a talk about Bank. They had 200 packages, and Bank from Mexico or something like that, and they said that they had to just make example app in every package so that you don't have to open many packages. But those are workarounds. When we have the solution for that, I think that it will be perfect.
Yeah, and actually, it's not that all of our developers were working only for 10 minutes and then a coffee break.
Sorry.
But we
exaggerated.
In the IntelliJ, there's this feature where you can actually exclude packages. So if you were in Squad X and you will probably also need to deal with Squad Y and Z, then you have the analyzer enabled for those, but all the other 55 packages are simply excluded, so the Dart Analyzer doesn't waste your RAM over them.
Also, some people don't want to use
IntelliJ. I think we have to cut there, sorry.
Okay.
Yeah.
All right, thanks a lot to Albert and Mateusz.